In this question, it is given that a car is moving horizontally towards left with velocity v, and the rain is falling vertically downward with the speed w. And here we have to find the number of drops falling per unit time. Basically, ratio. We need to find the ratio of number of drops falling per unit time on the top glass. This is the top glass, which is flat surface, and the another one is inclined surface, that is your front glass, and both the surface have same surface area, and we need to find the number of drops ratio. So first of all, we have to understand on which parameters our number of drops falling is depends. And let's relate this number of drops with electric flux. Electric flux is like number of field line crossing the surface area. So we know that the number of field lines crossing the area depends on the electric field strength and as well as the surface areas and its orientation. So we know that the number of field lines is represented by flux, and flux was E dot A. In the same way, the amount of number of drops falling on the surface depends on the velocity of the drops, and as well as the surface area and its orientation. Because if rain is falling like this and its orientation is like this, then no any drop will fall on the surface. So here, and also the area of also the surface area's magnitude, it's also depend on the surface area's magnitude, and the velocity. Why velocity? Because if its velocity is more, then more number of drop will fall in a less time. So here the two parameters is very important, the velocity and acceleration, on which our number of drop is dependent. So that's why I written there the number of drops depend on v dot a, that is v dot a. Why v dot a? That's similar to the flux E dot a. The number of drops proportional to v dot a. Here we find the velocity with respect to car, because in the car frame we actually see the velocity which is falling on the surface, and that will be equal to v I cap minus wj cap. For simpler function simplicity, I took the component. Then velocity of rain with respect to car becomes v I cap minus wj cap, and the area vector for the top surface, obviously we are analyzing the surface 1, which is top surface, and the area vector will be equal to sj cap. And here we took the dot product and we got the answer minus sw, and this will be our equation 1. Now we are going to analyze the surface 2. This is surface 2, and also its area's magnitude will be equal to s, and here we took the component, and the component will be equal to a sine alpha minus I cap. But in the question the magnitude of area, yes, that's why I changed the a with s here, and s sine alpha minus I cap plus s cos alpha j cap. This is the area vector, this is the velocity, and here we took the dot product for calculating the number of drops which is proportional to this value, and we got this answer minus vs sine alpha and minus ws cos alpha. Now here we took the ratio, because the question wants the ratio value, and after taking the ratio, this will be the answer, and this is matched with the option D. Thank you.